Hello and welcome to the video lecture on solved example of inverse Laplace transform. In this example, we are going to discuss the how to find the inverse Laplace transform by using a partial fraction expansion method for the repeated poles. So the example given is x of s is equal to s square divided by s minus 1 into s minus half whole square. And it is given that it is for a causal time domain signal. So the meaning of causal time domain signal means you have to multiply the signal by u of t. Now first represent this in a standard PFE form. So x of s is equal to a1 upon s minus 1 plus a2 upon s minus half plus a3 upon s minus half whole square. Now let us calculate the coefficients a1, a2 and a3. So a1 is equal to s minus 1 into x of s at s is equal to 1. So s minus 1 into s square upon s minus 1 into s minus half whole square at s is equal to 1. So this gets cancelled. So it becomes 1 minus half whole square, so which will give you 4. So the value of a1 is equal to 4. Now let us calculate the value of the coefficient a2. So a2 is equal to d by ds of s minus half square into x of s at s is equal to 1 by 2. So which is equal to d by ds of s minus half square into x of s is s square divided by s minus 1 into s minus half whole square at s is equal to 1 by 2. So this gets cancelled. So which is equal to d by ds of s square upon s minus 1 at s is equal to 1 by 2. Now let us apply the rule u into v. We will convert this into uv equation. So d by ds of s square into s minus 1 inverse at s is equal to half. Now apply u into v formula of derivative. So which is nothing but s square term will be as it is into d by ds of s minus 1 raised to minus 1 plus s minus 1 inverse as it is and d by ds of s square at s is equal to 1 by 2. So which is equal to now we'll solve this. So this is equivalent to s square first term will be as it is, then d by ds of this term is given by minus 1 into s minus 1 raised to minus 2 plus s minus 1 inverse will be as it is and it is equal to 2s at s is equal to 1 by 2. Now let us substitute all the values in this. So s square means it is equal to 1 by 4 into minus 1 into 1 upon 1 half minus 1 raised to 2 plus 1 upon half minus 1 into 2 into 1 by 2. So which is nothing but when we solve all this, we will get a2 is equal to minus 3. So this is our second coefficient a2. Now let us go for the third coefficient, that is a3, which we are going to calculate by our normal method. So now a3 is equal to s minus half whole square into x of s at s is equal to 1 by 2. So which is equal to s minus half whole square into put the value of x of s, which is nothing but s square divided by s minus 1 into s minus half whole square at s is equal to 1 by 2. Again this term gets cancelled. Now let us put this. So 1 by 4 divided by half minus 1. So which is equal to 1 upon 4 divided by minus half. So when we calculate this, we will get the value equal to minus 1 by 2. So we have got the values of all these three coefficients a1, a2 and a3. Now let us substitute all these three values in the above equation and let us write it again. So now see. So we get x of s is equal to 4 divided by s minus 1 minus 3 divided by s minus half minus half divided by s minus half whole square. Now this equation is in a standard form. Now we'll take the inverse Laplace. So inverse Laplace x of t is equal to Laplace inverse of x of s is equal to Laplace inverse of this minus Laplace inverse of 3 upon s minus half minus Laplace inverse of half divided by s minus half whole square. Now for this first term, let us consider the first term. So it is a standard e raised to at equation. So we are going to use the standard equation. Laplace inverse of 1 upon s minus a is e raised to at into ut. Therefore, Laplace inverse of 4 upon s minus 1 is equal to 4. Here a value is 1. So e raised to t into ut. Then for the second term also we are using the same equation. So Laplace inverse of 3 divided by s minus half, which is equal to 3 into e raised to, here value of a is 1 by 2. So 1 by 2t into u of t. So this is a second equation, and but only for this third term there is a square. So we have to go for the formula of t raised to n. So for third term we are using t raised to n into e raised to at Laplace transform given by n factorial upon s minus a into raised to n plus 1. Now you compare this with the third term, and in this you will find that the value of n plus 1 is equal to 2, and therefore the value of n will be equal to, let us calculate. So here if you can see n plus 1 power equal to 2. So what is n? N is equal to 1, and therefore Laplace inverse of third term is given by, n is 1, so it is given by 1 factorial divided by s minus a. So s minus a raised to n plus 1, and what is n plus 1? It is equal to 2. Okay. So and here if you see, it is a t raised to n thing. So when you take its inverse Laplace transform, it is represented by t raised to n, that means n is 1, into e raised to at. So e raised to half t into ut. So this is a inverse Laplace of the third term. So now we'll combine this result and we'll write final answer. So the final answer x of t is equal to 4 into e raised to t ut minus 3 into e raised to half t ut minus 1/2 into t into e raised to half t into ut u of t. So this is the final answer for this repeated roots. So if you like my video, then please share the video with your friends, and if you have not subscribed to my channel, then please subscribe to my channel. Thank you guys. Thank you so much.